Okay, so the next reaction up to bat is called Kiliani-Fischer. And Kiliani-Fischer, say that 3 times. Kiliani-Fischer, Kiliani-Fischer, Kiliani-Fischer. Doesn't that make your tongue feel happy? So Kiliani-Fischer is basically just a fancy term that means we're going to elongate the chain. So elongate, right? We've often talked about these processes that elongate a carbon chain. They're very special when we run across them in organic because that helps us make things that we traditionally maybe can't do if we were just faced with keeping the same carbon number, right? So this is a way that we can take maybe a 4-carbon sugar and convert it to a 5-carbon sugar, or a 5-carbon sugar and convert it to a 6-carbon sugar. That's all that we're doing here. We're increasing the carbon chain by 1. So we're extending the backbone of the carbohydrate. So we're elongating the carbohydrate molecule for us. And that's what Kiliani-Fischer is all about. So we've got to kind of figure out, okay, well, what reagents will allow us to do the elongation? Okay, so again, we're not going to worry about mechanism. Not on a test and not on a quiz. Maybe the homework will ask questions about mechanisms and that kind of thing, but you know what? You've got the book for your homework, you've got the reading material for the homework, you can kind of work through those issues on your own. For us though, for the quizzes and the test, we're not going to be asking about mechanisms, not in the biochemistry class. We're going to kind of put a back burner on those curvy arrows for a while. And if we take a look at the Kiliani-Fischer, basically what happens here is that we start off with some type of sugar. It could be an aldose or it could be a ketose. It doesn't really matter. However, most of the time we will be looking at aldoses. Okay? So aldoses are what we will focus on. Alright, so we take this sugar and the very first thing that we add to it is a C triple bond N. And hopefully you pick up that that is a nitrile group. Hopefully you pick up that this nitrile reaction and a aldehyde reaction we have talked about already, and this was back in the carbohydrate lectures, which is where the previous class ended up. So this whole mechanism and this whole reaction is nothing new. The only new part about it is that we are talking about starting with a sugar now instead of just simply a molecule with an aldehyde group on it. So it's an aldehyde group as well as multiple OH groups. So that's the only difference. We take the sugar and we add nitrile. And we add nitrile in an acidic environment. So most of the time this acidic environment is hydrochloric acid. So this is kind of step number 1, nitrile and hydrochloric. Step number 2 is a hydrogen addition with palladium and BaSO4, barium sulfate. Then we have a third step of the Kiliani-Fischer, and what happens is that we add acid yet again, typically in the form of hydrochloric and water. And this ends up with our elongated sugar. It elongates by 1 carbon only, and that is it. The problem though is that there's 2 choices most of the time, right? And these 2 choices are because the carbon is chiral that we add on. So does the OH group go to the right hand side with the H to the left, or does the OH group go to the left hand side with the hydrogen on the right? Either one of these will work. It doesn't matter. That's the beauty of Kiliani-Fischer, but that's also sometimes the problem of Kiliani-Fischer. Sometimes you want a specific carbohydrate, but Kiliani-Fischer, when it elongates the chain, that extra carbon's going to sandwich onto the backbone, and you've got no control over which direction that OH is going to point in. So you're going to end up with a mixture of different sugars. So that's the story with Kiliani-Fischer. So in the first step, hydrogen cyanide adds to the carbonyl group. This is a review. of basically the carbonyl reactions that we ended with in the previous course. It converts that carbonyl carbon into an asymmetric center, right? Because we've added a group, that carbon's got 4 different groups on it now. That is a chiral carbon. So stereochemistry becomes very important even in the very beginnings of the reaction. The C triple bond N, well, I can put a keyword up here if I want. It is reduced, and it's reduced to an imine. Now, if you don't know what an imine is, I would refer to you to go back in your chapter, go back to the carbonyl lectures, and figure out what an imine group is, because that's something that we've seen as well. So this requires the palladium catalyst. So that's kind of what happens here, right? This H2 is going to come in, look at this nitrile group, convert it to an imine, and then we go on to step 3. And step 3 is a continuation onto that, and the 2 imines are hydrolyzed by 2 aldoses, right? Okay, so we end up with this mixture of different sugars in the very end. So let's take a look at an example of Kiliani-Fischer. I promise this is not going to be difficult. This is not bad at all. So let's say that we take D-xylose, and we want to use Kiliani-Fischer on D-xylose, and we want to know what kind of sugars could we make using Kiliani-Fischer. So D-xylose is something that I probably don't want to memorize, but it's something that I want to find in the chart. And this is a C double bond OH up here at the top. And then down here below is CH2OH. And then xylose is a pentose. So there's 5 carbons in total. So there's 1, 2, 3, 4, and 5. And the orientation of the OH groups are right-handed, left-handed, and right-handed. So here's D-xylose, and I'm going to undergo Kiliani-Fischer. Alright, so I can just write Kiliani-Fischer here if I want, or I can go through and list all of those horrendous reagents, and I can put those on the arrow in step number 1 and step number 2 and so on. So it's up to you and how you see them. Just keep in mind though, when you see this nitrile group, that's almost a dead giveaway that Kiliani-Fischer is going on. So the nitrile group is the sign that Kiliani-Fischer is going to elongate the chain. It's bringing in an extra carbon to the picture. Okay, so here's the story. This is how you basically figure out what type of products get formed by the extenuation of the carbon backbone. So we are going to draw D-xylose all over again. C double bond OH. And then down here below is CH2OH, and we said that there were 3 carbons, right? 1 here, and then the OH here, and then the OH there. Okay, so this is the structure of D-xylose. Kiliani-Fischer is going to come in and sandwich another carbon right up here at the top. That's where that extra carbon is going to go. It goes up at the top near the carbonyl bond. The nitrile is basically attacking the carbon of the carbonyl, and that is where that carbon goes, right? So in a nutshell, that's kind of how you want to think about the mechanism. Even though we've not covered it or addressed it formally, maybe that will help you. So this is where that attachment is going to happen. Now you've got a choice. The OH group could go here to the right hand side, or the OH group could basically go to the other side as well, right? So the OH group could have went at this location instead of this location. But all the other groups, they stay the same. Nothing gets touched as far as the remainder of the sugar goes. It's only this area here that gets attached. That is it. That's the only thing that changes. Now, the question might actually want you to go through and draw the structure, and if so, that's how you draw the structures. You draw D-xylose in this case. You add an extra carbon up at the top, and in one version you put the OH to the right, and the other version you put the OH to the left. Okay, it's as simple as that. What maybe would get tricky, if anything, would be to name the sugars that you've made. Well, I need the actual chart to go through and name these structures. So I've started with a 5-carbon sugar. I've now ended up with a 6-carbon sugar, right? Here's carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. So I've got 6 carbons in total. I look at the positions of the OH groups. It's right, right, left, right. And I go to that chart and I find the one that's right, right, left, right. And I'm going to see that this one is called D-gulose. So I've made D-gulose as one of my products. And then down here at the bottom, the same thing is going to happen, right? This is a 6-carbon chain, but I need to look for a sugar that has the OH left, right, left, right. So if I try to find the one that has left, right on it, I'm going to see that this is called D-idose. So that's the other product that I could end up with the Kiliani Fischer. It doesn't get any more complicated than that, folks. I mean, really, honestly, that's all that we're doing in these carbohydrate reactions. We're pulling back on the mechanisms, we're pulling back on the curvy arrows. We're not really going to be focused on that this semester. We're just looking at properties, and we're skimming over some of the reactions that these things can undergo. And Kiliani Fischer is one of those, like oxidation and the one in the basic environment. We're looking at it, we're introducing it, we're just kind of explaining what it does, and that is it. And as long as you can keep that separated, then I think that you're going to do well on these quizzes and tests. Again, the homework might go into a little bit more detail, but because of that, you've got the book, you've got a whole month to do these assignments, you can work on them as you go, so that's a different story. But as far as the quizzes and tests are concerned, this is about as complicated as you're going to see it get as far as questions go. So this is an example of the type of question that you will see on the test with Kiliani Fischer. Here's a sugar. Kiliani Fischer undergoes what kind of products do you get, and name them. So you'll have that chart in front of you. I'm not taking that away either, so I can't really make it any easier than that. Okay, so that's all that we're going to mention about Kiliani Fischer. That's it. So the next video, if we can lengthen the chain, then we can shorten the chain. And in the next video, we're going to see how we can take a sugar and remove a carbon from the backbone and what kind of reagents are needed. So once again, the reagents for the Kiliani Fischer is nitrile and acid, and then hydrogen and palladium, and then acid again. So let's look in the next video on how to shorten the carbon backbone.